Okay, so let's do a problem. This would be a good test problem. This one's going to check your inverse trig functions. It checks your product rule abilities. It checks your chain rule abilities. So a lot going on in one problem. It says differentiate y equals arc sine of x plus x times the square root of 1 minus x squared. So let's do this one step at a time. We have y prime would equal, what's the derivative of arc sine of x? That's 1 over the square root of 1 minus x squared. Yes, you do need to memorize that. You absolutely want to have that memorized, okay? Plus, now we need to do the chain rule. The first is x. The second is the square root of 1 minus x squared. So we do the first, which would be x, times the derivative of the second. So let's drop the power, would be 1/2. 1 minus x squared to the power minus 1, which would be negative 1/2. But then remember, you have to multiply times the derivative of the inside. Okay, so be really careful with that one. That's a chain rule problem. 1/2, 1 minus x squared to the negative 1/2, but then you need the derivative of the inside, all right? So that's first times the derivative of the second is what we've done here. We've done 1 d2. Now we need plus 2. 2 was square root of 1 minus x squared. That's the second function. Now we need d1. Well, the derivative of x is just a 1, okay? All right. We got a lot of simplifying here to do. Let's be careful. Square root of 1 minus x squared is a negative 2x. And then I see that the 2's are going to simplify. So let's be careful and see what we have. Let's put it all together. Here I have a 1 over the square root of 1 minus x squared. The second term, I'm going to take this 1 minus x squared to the negative 1/2. I'm going to throw it into the denominator and make it a square root. And then in the numerator, it looks like I have an x times a negative x, which would be a negative x squared. And then I have plus, and then I still have that square root of 1 minus x squared. All right. I personally, I'd be okay with you answering your problem this way. But you know what the book's going to do? The book's going to sit here and try to get a common denominator and combine it all together. So let's see what we can do if we get a common denominator. If we get a common denominator, it's going to be the square root of 1 minus x squared all over the square root of 1 minus x squared. So what are we going to have? I'm going to go ahead and combine the first two because they already have a common denominator. So it's 1 minus x squared all over the square root of 1 minus x squared plus... Now on this one right here, 1 minus x squared, square root of 1 minus x squared times square root of 1 minus x squared is 1 minus x squared, and that's all over the square root of 1 minus x squared. So combining those, I'd have 1 plus 1, which would be 2, and then I'd have minus x squared, so that'd be minus 2x squared, all over the square root of 1 minus x squared. That's perfectly fine with me. You could even go further. You could factor out a 2, so this would be 2 times 1 minus x squared all over the square root of 1 minus x squared. And then you could technically simplify this and say the square root of 1 minus x squared on bottom and the 1 minus x squared on top would simplify into the square root of 1 minus x squared on top and a 1 on bottom. So this would be 2 times the square root of 1 minus x squared. Wow. So I'm going back to I'm gonna say this one right here. This is my answer. I like that one right there before I got a common denominator with everything. It doesn't really matter. The most simplified version that I can find of this one is 2 times the square root of 1 minus x squared. But that's truly not what I would have given. I would have given on the test 1 over the square root of 1 minus x squared minus. I mean, it could have at least combined these two, I guess, because they already have a common denominator, right? Plus the square root of 1 minus x squared. So it could have at least done that step. The first two fractions have a common denominator. I could at least combine those, but I would not have expected you to get a common denominator of all three terms and simplify all three terms. It's just a waste of time, in all honesty. Okay, so let's look at this. It says the following is summary of all the derivative rules we have covered and should be memorized. Again, I am not joking. Every single one of these rules should be memorized. I'm going to show you personally the only two that I didn't memorize when I went through calculus are number 23 and 24. So all we have done is repeated every single one of the rules that we learned in the previous sections. In fact, in the last section, we summarized every single one of these rules. The only new rules that we have added at this point in time, the only new things from the previous section is numbers 19 on, and 19 through 22 are the ones that I truly want you to memorize. So, good luck memorizing the rules. Lots and lots of practice here. Make sure you know how to prove the derivative of the inverse sine, prove the derivative of the inverse cosine, and prove the derivative of the inverse tangent. If you can prove those, and again our book calls those arcsine, arccosine, and arctangent. If you can prove those three, you can do the problem on the test if I ask you. Otherwise, just memorize those rules, and I'll probably only ask you 1 or 2 questions on inverse trig functions on the test.